Yes. Yeah, yes.
Yeah, we have what we call Berkeley time, where students get out of class all over. 10 minutes to walk over, so we really start for the 10 minutes. Wait, that's not awesome. Do anything else to do?
Working in this, we have what's called lift time, which is that the scientists would start right on the dot of when they could yeah, not everything.
This is like a metaphor for the DC Berkeley difference.
But NIST maintains the atomic clock too, so that was another thing. It's not a boulder, but still, it's your clock was exactly accurate.
Okay, that seems important too.
Yeah. It's a particular physicists are always tough.
Hey, right.
I like that. It's fun. It is humorous. I like it. And we also talk about musical about listening it to them, because you can't just make it better, you can just make it perfect. That's accurate. Yeah. Oh, it's a measurement. That's it's yeah. I look at locals.
You say you're studying agnostic?
Yeah.
I'm in an agnostic class, but I'm actually a pollinator science master major.
Oh, Andrew's
So
class?
kind of bridge.
Yeah,
Yeah.
It's been a really fun time.
it's cool. Yeah, I took it when I was a grad student at Saunders. Yeah,
So
yeah, I did my capstone on state level
Hi.
and.
Oh, very cool.
Yeah.
Like in general, or focusing on
Focusing on California as provenance legislation, like labeling and watermarking of content.
Oh, okay.
Like cryptographic applications that are under development.
I'm trying to do my like final policy medical class about that.
Oh, cool.
I worked with Honey Curry.
Oh, yeah.
Who's
Okay, yeah.
like super into digital forensics. I had those collapses and they just finding themselves. So I was gonna try to maybe do less sort of like a policies framework, but more of like corporate messaging strategy about like if you're ingesting this content, it's gonna be bad for you in the end. So you should preemptively watermark it. So
Right. Right. Yeah, it's crazy how China actually has really good legislation.
Really?
everything's marked like on all social media in China. Yeah, if you post something, you're required to mark whether it's AI generated or not. And we don't get anything like that here.
Yeah.
So that's flopped. I feel like it's such a big issue. People don't know what's real.
Exactly, and it's really interesting also like with.
So
With OpenAI closing down Sora recently.
Yeah.
Sort of like the executive is sort of seen as a market
Mhm.
incentive kind of with standards was not so unprofitable and kind of indicating a social shift away from
Mhm.
AI generated.
Yeah, that's interesting. Yeah, how it's like developing like towards like agents. I think that's what I want. I want to sound very
Yeah, exactly.
I don't want like artists.
Yeah.
I think people are like getting on board with that.
I think so too, yeah, and I hope there's enough sort of like shift, it does feel like things are going that way, like it's teaching me more integrated with children, gathering stronger, wanting it to be reflected in legislation, everything.
Definitely. Yeah, definitely. Do you know Sarah Barrington?
She still for us, yeah.
Oh, cool. Yeah, we've been doing some research together.
Yeah.
My background, I'm with IAS, but my background is in human rights and conflict. So we're doing research on deep fakes and conflict, but especially gendered aspects. Most impacts on women. Yeah, so it's been, just to do a deep dive on it.
Very interesting.
Yeah.
We'll keep an eye out for it, I think I follow her on LinkedIn, so is that this?
Yeah, she's doing such cool research on audio
Mhm.
deepfake detection. Yeah. And she just finished her dissertation, so she's very busy.
I can imagine. Yeah, great.
Yeah.
Yeah.
How are you? Yeah, we haven't talked about it. Are you free after?
Yeah, I guess I don't
Yeah, for excited.
Yeah.
I think we could probably start. Yeah, people will probably trickle in. Yeah. So hi, everyone. Thank you for coming. My name is Jessica Olney. I'm the Executive Director of the Institute of International Studies. I'm new around here, so come say hi if you want to learn more about what IIS does. We have a big list of April events covering tons of different topics, but we're super excited to have our senior fellow, Deborah Glass, and Mary Saunders here today. So Mary is the senior vice president at ANSI, the American National Standards Institute. She serves as ANSI's spokesperson and liaison to federal, state, and local government agencies, as well as to Congress and congressional staffers, leading efforts to advance the Institute's positions and policies across government. So she'll talk today about standard setting, I think across AI, some biotech, even quantum policy in an era where deregulation is the name of the game at the federal level, and looking how standards can address some of the need for safety as these technologies advance. Prior to joining NC, Mary was the Associate Director for Management Resources at the Department of Congress at NIST, which I'm sure some of you are familiar with, the National Institute of Standards and Technology. And Deborah is going to speak in conversation with Mary. In addition to being our much appreciated senior fellow, Deborah is a political scientist, a PhD, a public policy professional, and has a long career of experience working on economic policy, trade policy. She has experience in trade negotiations, direct foreign investment, and intellectual property rights protection, including experience at the US Senate, the House, Department of Congress, Department of State. So it's great to have Mary and Deborah here and, help. One thing IIS tries to do is bridge that kind of DC Berkeley gap, those 3,000 miles or so in between. So we really appreciate having folks come because a lot of students are still interested in what it might look like to work at the federal level in this interesting era that we're in. So we'll have some time for Q&A, and feel free to ask questions more about thematically, but also what the work looks like if you're trying to think through that for yourself. So yeah, we'll let you take it away.
Thanks. You want me to start?
Sure, I was going to introduce you, but I think Jess.
Yeah, that's okay.
A great introduction. Why don't you show us the way?
Thanks, Jess. And thanks, Deborah, for making this possible. I'm really happy to be here. It's a pleasure I love talking about these issues. I have a political science and economics background. I have an MPA So I can speak to the value of a master's in public affairs. My field was international relations, but that has stood me quite well throughout my career, both with the federal government and now in the private sector. So I speak to the value of general background in how to do good analysis and how to present policy papers, how to parse out the various issues, pros and cons. It's really helped me a lot through all of my different jobs largely in Washington, but moving from space to space. And I'm going to talk about, I want to spend a few minutes, maybe about 20 minutes, talking generally about the intersection of technology, standards, and laws and regulations to give you a sense of the space that I deal with pretty much every day in Washington. I spent a lot of time when I was at NIST talking to foreign governments about how the U.S. system works, both standards and regulations, and the market-led system. And I continue to spend a lot of time in ANSI talking with our U.S. government policymakers about the importance of private sector leadership and the public-private partnership. But primarily over the past 2.5 years about technology issues, because these are very hot issues. Technology and technology changes have been around with us for many, many years, but it's a really hot topic in Washington and globally these days. So just to get us started, I mean, technology, generally speaking, but certainly what we're looking at now is evolving very, very rapidly, much more rapidly than say 20 to 25 years ago. And we've heard it called, some of these technologies are called disruptive technologies. The changes are highly disruptive. It can be a positive thing, can be a negative thing if the institutions are not, and the market is not prepared. There are also, some of them are known as pervasive technologies. And AI is one example of that. It is pervasive. AI is not a freestanding, well, it is, but AI is important across the entire range of technology application areas, and it is affecting almost every economic sector of the economy. So not only is technology changing very rapidly in the current environment, countries and governments are competing intensely for technology and business advantages. And there's always been competition going on in the international trading system. It is very intense these days for a variety of reasons. There's a mix of national security interests and economic competitiveness interests, and national security has come much more to the fore in terms of competition. And actually, we're seeing a world in which the trading system that we knew when we were coming up in the policy field is fracturing. The World Trade Organization has been around for quite some time, but the practices and policies that are represented in the WTO have been less and less, I think, less and less implemented, less and less paid attention to in the current environment. So we're seeing not only shifting technology patterns, but shifting trading patterns, and supply chains and supply chain issues are becoming ever more critical, because supply chains are vulnerable, as they never have been previously. So there are rising geopolitical tensions, as I mentioned, and I think one important point, which is may have been a little bit hard for some of the folks in Washington to pick up on, is the U.S. is no longer dominant. We are a player and a major player in some of these technology areas. We are not the major player of the United States in all of these technology areas. I wanted to start with this slide, not because it is a comprehensive representation of every critical and emerging technology, but because I think it, and I'll explain a little bit, it shows the interactions and intersections among technologies. In the policy space, we don't consider any of these technologies in silos independently. They all interact and interconnect. And this schema was put together a couple of years ago when the previous administration, the Biden administration, the Department of Commerce was looking across the federal space and developed with White House support the U.S. government's national standard strategy for critical and emerging technologies. It's a mouthful, but it was about a year or more in its creation, and ANSI and other private sector entities were actively involved. But they put together this very targeted list of technologies of significant interest. If you go to the Office of Science and Technology Policy, every year they put together a list of critical technologies where the U.S. agency, federal agencies look at R&D, focusing R&D funding in particular areas. And the OSTP list is probably 17 or 18 technologies long. It's extensive. including a lot of technologies you won't see here, and a lot of technologies you might think you should see here, like robotics, for example. But the reason I put this one up is because it shows the three technologies that we can talk about today, or any others, artificial intelligence, biotechnology, and quantum information science in the emerging area. And then you have the critical technologies. And the reason they're listed as critical is because we're in a digital age now. So all of these technologies are interconnected. They're all digital in some way, shape, or form. And cybersecurity is critical for anything you connect to the internet automatically is not secure unless you are protecting it, whatever it is. It can be a machine, it can be a process, it can be a set of data. So cybersecurity is key across all of these technology areas and many others. And privacy, and by privacy, I mean mostly data privacy, is a really important issue, which is also pervasive across all of the technologies, certainly in, well, all advanced communications, artificial intelligence. I think in all of these, you see the issue, because they're all created or enabled by data, large amounts of data in the case of artificial intelligence, and certainly application in biotechnology, and that those data belong to some entity or some individuals. And so there are issues of data security, data privacy, and data, what's called data provenance. Where does the data come from? Is it good data? That's why they're listed as critical areas. And then you have what are called application areas. These are not new technologies. Microelectronic chips, semiconductors, been around for a long time. But advanced microelectronics is not only a hot trade issue these days and a hot technology issue, but it is also widely applied across a wide range of manufacturing and service sectors. Automated and connected infrastructure, which is vehicle infrastructure, aerospace infrastructure. It is also critical in a wide technology application areas, energy technologies, energy and electrical grid for a long time. All widely very much affected by all of these other technologies, the influence of artificial intelligence, and also the security issues and so on. So I like this because it sort of represents the connection across all of these technologies, and those connections are very important. So I should have started with the 3 clocks model, which I'm going to express. So that there's technology, standards, and laws and regulations. And a colleague of mine in the corporate sector has a very good handle on what's going on in the intersections of all of these areas, has said that technology moves very, very quickly. If you have 3 clocks, the technology clock is moving extremely quickly in these key areas. The standards clock, little bit slower, and I'll talk more about standards and what that whole enterprise looks like. So slower, but it's connected to the standards clock is connected to the technology clock, because standards are an important platform for innovation. They're also an important vehicle for commercializing new technologies. You have expectations and agreements like interoperability and other technical areas that enable technologies to be deployed more broadly. So standards are important in a lot of different aspects. And then the slowest clock is the law and regulation clock. I mean, typically from the US perspective, we think it's a good thing that the regulatory and the legal clock is slower, because we tend to have a market-driven economy, and there is a preference to allow the market to develop and evolve, and the laws and regulations should be brought into effect when there's a market failure, or there's a public interest that extends beyond the market interest. So we tend to allow the market to try to regulate itself, self-regulate in many areas. So the legal clock and the regulatory clock tends to lag, but that's creating some issues these days that weren't, I think, an issue, say, 20 years ago. So I guess I should have asked, moving past the technology relationship, I'm going to talk about standards. So I was just reading a book. I started a book on the way out by Tracy Kidder, who's just died recently, but he wrote a lot of books about a variety of different areas. And one of them was written in 1980 it's called The Soul of a New Machine. It's about data general and the creation of a mini computer that competed with DEX. It's just the early computer stages before the internet was actually broadly in existence. TCP/IP, anybody familiar with that? The internet, the first internet protocol, 1981. That's a standard. It's an internet protocol which enabled a huge amount of communications to expand across the whole internet space. But this is all prior to the internet stage. So that's an example of standards actually enabling a huge amount of change and bringing us to what is a digital economy these days. So next slide. Thanks. So how many of you are, when I say standards or standards organizations, how many, does that ring a bell? Okay. So yeah, I've been doing this for like more than 30 years. So I mentioned these are technical, they're technical documents currently. So TCP/IP, which is the first internet protocol, is a technical set of documents with relationships. HTML, how you present information is a standard. Wi-Fi, IEEE 802.11, local area. Sorry,
I'll do more.
Yeah, is local area networks, wide area networks, metropolitan area networks. These are all the wireless standards that enable Bluetooth and any wireless communications. Those are very basic standards that are written. They're all written by technical experts that come to a particular standards table, and I'll talk a little bit about what those may look like, with an interest in reaching a consensus on basically a minimal viable product. So it's not the best, it's not going to be anybody's best, but it's going to bring together a bunch of experts from a variety of different walks of life. Not only technical experts from companies, but from universities, from government agencies, because technical experts work in government agencies, and agencies have an interest in robust standards in their mission areas. And they all come together and they deliberate and write a consensus document, which then is hopefully applied in the marketplace. And if applied, these are pretty seamless. So when you plug in if you charge your phone, the charger, USB-C charger now, which is the common charger, those are all standards. HTML, I mentioned, any of the internet protocols. When you look up something on the web, you're navigating through several standards that support your ability to retrieve information. So it's not a simple environment, however. Unlike in some countries which recognize only certain venues for standards development, there are a variety of different venues and ways to come together to develop standards. So that one way of characterizing the landscape is to represent how are the interests represented. So in IEEE, the Institute for Electrical and Electronics Engineers, for example, individual experts come to a particular table, to the standards committee, to talk about a particular technology area, and they come globally. IEEE has, I think, 40% of their members are outside of the US. It can be individual organizations, so companies, still individual experts are coming to the table, but they're representing a company or a university or a federal agency. So that's an organizational representation. National bodies or committees. ANSI is not a standards developer, but one of our roles is to manage the US representation of two major international standards development organizations. The International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC. They've been around for a long time. IEC's been around since 1875, and ISO's been around since 1945. And the representation is national bodies. So ANSI is the national standards body that administers the process by which national positions go into ISO and IEC standards. You ever heard of ISO 9000? Yeah, okay, quality management system standards. The US representation is through ANSI into the TC 176. And a range of other technical committees. They're working on a huge range of areas. And then national governments, so treaty organizations, International Telecommunications Union, International Civil Aviation Organization, I can go on. Those are all treaty organizations where actually governments represent interests. So the State Department manages US representation in ITU, although the State Department involves a whole range of private sector interests to develop that position, but still these are treaty organizations. And then how are decisions made? Is it consensus, which we typically talk about, which means doesn't have to be substantial agreement. There can be disagreement, but the disagreements are managed through the consensus process, and the end product is a largely agreed document. It can be one expert, one vote, can be one organization, one vote, can be one country, one vote. There are a variety of different ways decisions are made. And then membership. As I mentioned, ISO and IEC are open to national body representation. They're open to any country that has a national standards body. There are 160 members of ISO. But the way you're represented in the decision-making process is unique to those organizations. If we open any paying member, lots of talk a little bit about consortia and fora. So companies pay to participate in a particular organization. Can be limited to certain classes of members. So that's sort of one way of parsing out this very complex standard system, which I find fascinating, actually. And it is not as opaque as it may seem to be. There are liaisons and interconnections across various organizations that make the system work. And depending on the technology area in which you're focusing, there may be a small number of organizations that are relevant. There may be a large number of organizations that are relevant. But just like there are interrelationships across the technologies, there are interrelationships across the standards community. You mentioned in the title, safety issues. Well, certainly safety is an important area for standardization. In addition, now security is also an important area for standardization. Performance, interoperability. In the AI case, standards for determining bias, standards for determining, and there are standards for determining what is a trustworthy AI algorithm or system. There is a way of calculating that and standardizing that. So the topics are range widely, but they all exist within an ecosystem where there's communications. Standards in particular create upstream safeguards. So when I said the market, there's a lot of market leadership and market leading private sector leadership in the US. The standards that are developed largely by private sector participants with US government participation as well are serve as safeguards for the technology as it evolves. Not always completely adequate, but they are safeguards with respect to the safety, with respect to the security, with respect to the interoperability, and so on and so forth. And there's participation by government, there's participation by research networks, there's a lot of collaboration going on, which manifests itself in some cases in the standards ecosystem. So you can go to the last slide. Another way of looking at this, as I mentioned national participation. So ANSI in the blue section is where ANSI is directly responsible as a coordinator. I mentioned we are the national standards body in ISO and IEC, US-based standards developing organization that adheres to internationally accepted principles. We have members who, the State Department is a member, the Department of Transportation, government agencies are members of ANSI, and they bring their standards interests to the table. And then in the US, the direct participation mode is very important. We have a very broad definition of international standards in the United States, which has evolved over 30 years, which is that a globally relevant standard is relevant because it is used widely and because it adheres to principles, openness, transparency, consensus, due process, not by what organization developed that standard. So direct participation, and you may be familiar with some of these names, or when US experts come to the table, they're not representing a country or necessarily an organization. IEEE, ASTM International is another major standards developer, SAE, Society of Automotive and Aeronautics Engineers, and there are others that have major influence and produce books of standards that are widely used globally. And so those are all international standards from the perception of the United States. The definition in Europe is much narrower, and the definition in some other countries is narrower as well. That's a point in the trade space. And then very important rising area of activity is consortia and de facto participation. And I would extend that beyond the examples I have up there: W3C, World Wide Web Consortium, Internet Engineering Task Force, IETF. ORAN is Open Radio Access Networks. That's in the advanced communications area. And then you've got industry, you've got Bluetooth, you've got Windows, you've got industry practices. But I would extend the consortium de facto column to also open source software and open source standards. Very important in a lot of these technology areas, in AI, in advanced communications, in a wide variety of new technology areas. Open source is a layer on top of the infrastructure of the standards that lie underneath it, which enables interoperability and broader usage. So, as I said, we differ in the US. We have a broader definition of what are globally relevant standards. Our definition is enshrined in the World Trade Organization, but it continues to create issues with some of our trading partners with respect to acceptance of global standards that are developed by ASTM or IEEE or others, which have to go through additional hoops to be recognized by other governments, including the European Commission. So standards development actions, as I tried to explain, are expanding dramatically in response to the technology push. There are multiple venues, there are a lot of global players. They're not operating in silos. There's interconnections through webs of liaison. If you talk to some of our, not even the government participants, but government or corporate participants, they're in a variety of relevant standards organizations, depending on who's working on the technology, where they have an interest. Take Microsoft as an example. They are very active in ISO and IEC in areas where those standards are relied on primarily by governments, because it's important to Microsoft and other providers of ICT equipment and digital services to be participating in standards development activities where governments will rely on those standards as part of regulations. They're also active in IEEE and many other areas, as well as very active in consortia. If you talk to folks in the information and communications technology arena, Microsoft has, I don't say, is engaged in 100 consensus standards development activities. They have at any one point in time several thousand consortia activities that they're participating in. It's a very important part of their business, because they may build into consensus standards, they may not, but they're a very important part of moving the technology forward in the information and communications technology space. So one issue I wanted to point out as I move into the law and regulation area is that geopolitics is fracturing this system. The global standardization system has existed and worked relatively well, very well from our perspective, from the US technology perspective, for many, many years. And geopolitics is really throwing a wrench into the process because of the sort of moving away from the open trading system, which we knew for 30 some years, to more market protection, trying to gain advantage in technology through gaining advantage in particular standards arena. So rather than consensus, trying to dominate a particular process, and just intense competition, which is somewhat counterintuitive in the global consensus process. There is always competition, and companies are coming to a particular standards development. They're sitting there with their competitors. They know that. That's a good thing. You're there so you can talk to competitors and share information which is not proprietary, get a sense of what the market looks like, and move to a consensus document that helps everybody. But geopolitics is making this, I think, quite a bit more difficult. And a couple of examples are the trade policies in two of the recent administrations, with an interest in protecting national security, so constricting access to some US technologies through export controls, and also potentially looking to restrict access by certain other countries' companies into global standards activities. And the whole issue of tariffs and trading back and forth to align with like-minded allies, and sort of in smaller groups of countries and companies getting together versus broader consensus groups. So it's been an issue for quite some time, not just in the current administration. I think a key problem that we see in this geopolitical competition creating issues is that trust is being undercut. I mean, for many years, the trading system and the technology system and standards in particular was built on trust. Come to the table, have open about what the intentions are, you engage in discussion and come out with a relevant document which benefits everybody. And trust is at a premium these days. The US is no longer the dominant technology supplier. The US, unfortunately, is no longer a trusted participant in the global environment, and in some cases. So we're looking at a significant change in trade policy as well as in technology policy. So just briefly, I don't have a slide on the legal and regulatory framework, but I mentioned that's the slowest clock. So you've got technology moving very quickly and standards moving a little bit more slowly, but managing in areas where standards are leading indicators of technology commercialization versus lagging indicators. In areas like quantum information science and biotechnology, standards are leading indicators. So you see standardization in certain areas before you see broad commercialization. In AI, standards are a lagging indicator. So you saw a lot of commercialization of AI algorithms and AI systems. And then coming behind are issues of trust and transparency and bias in the data. So the standards kind of lag to some extent the commercialization of AI as a thing. But what we're seeing is that the legal and regulatory clock is again a little slower. And while that hasn't been an issue historically, in the current situation, the frameworks are strained. In some cases, lagging substantially behind both the technology and the standards, which creates something of a gap between market activities, which may be supported by standards, and then the legal and regulatory framework. And in some cases in AI, there's a rush to regulate in the EU, for example, in the absence of standards. Standards aren't there yet. So it creates a little bit of an issue for compliance when a regulated entity is being asked to comply to the EU AI Act. The standards have not yet been delivered. So how do you comply? Take your best guess. I mean, it's a serious situation. And then we have a sort of the reverse situation in the United States where it's a light regulatory touch with reliance on market drivers and market responsibility. And the existing regulatory structure, which to some extent is robust enough to deal with AI challenges. But there are also significant gaps that are developing in that area as well. So, and the question is, from the regulator's perspective, how best to leverage standards are critical underpinning for regulation. They're very important tools, how best to leverage them, how to time regulation so that it works well with the necessary standards supporting it. And one important point, which is particularly true for AI, is that regulators have also focused on upstream safeguards. So standards are upstream, typically, safety, security, interoperability, and regulators have focused on what are called upstream safeguards. And what I mean by that is, in the classic sense, you regulate a product. So a manufacturer produces a product or a process, and the entity puts it on the market. If it's a regulated sector, it has to get approval from the Food and Drug Administration, or the Department of Transportation, or whatever. But that product is static. The product or the system or the process is static. That's not the case currently in the digital economy. So we have digital products. We have software-enabled medical devices. We have AI-enabled medical processes, radiology assessment, for example. You put a product or a digital product or a classic product on the market, and software updates will change how that product operates. So from the regulator's point of view, it's a question of, do I need to recertify or re-review that product because it has changed dramatically enough that it's not what I approved? Or do I, as the FDA has done, develop a partnership with the medical device manufacturers so that they determine there's close communication between the FDA and the medical device manufacturer, and the manufacturer will let the FDA know this software update will change dramatically the function of this particular device or process, and therefore it requires greater communication. But I think the issue for regulators is you can't just look upstream these days, because what's getting put on the market isn't what's going to exist in a few months for very good reasons. A lot of software updates, AI changes, data changes, and so on and so forth. So regulators are having to move to look at not only upstream regulation, but surveillance of the digital products and services once they're on the market. So what does that mean? You require manufacturers to have audits periodically. This is something that's been talked about in AI for the developers to operate risk management frameworks that are transparent and are evident, to be audited by third parties to certify that that manufacturer is complying with their own risk management framework. There are lots of aftermarket sort of processes and safeguards that are being looked at, which didn't exist in the classic product market. I think that's something to think about. And then we need to consider, I mentioned the downstream issues. We also need to maintain a careful balance between regulation and market drivers. There are two extremes. I don't think one extreme is innovation without regulation, and the other extreme is regulation without innovation. And the truth is somewhere in the middle. So the US is typically known as a market where there's innovation with light touch regulation, typically. Depending on the risk of the product or the process. And also reflecting our federal system, where the federal authority doesn't preempt state authorities. There are state authorities in certain areas. And then the European Union is more of an example of regulation in advance of innovation. And that has to do with how the market evolves to some extent in Europe. They're looking at now what is an internal market of 27 countries. So to try to harmonize regulations across a wide variety of national entities, there tends to be a greater reliance on the notion that we will identify the risk at the European level, and we will legislate to minimize those risks, with the distinct possibility that innovation is slowed down or restricted, because they have a very diverse market and there's a very different set of interests than there is in the United States. So I think there's no example of regulation with no innovation, but I think in terms of a schematic, the US is closer on the side of market innovation with light touch regulation, and the European Union is more closer on the other end of the continuum with regulation in advance of innovation, or just taking into account that innovation may take place much slowly, which has created a lot of issues in Europe. They have done self-assessments about why European technology providers are not as competitive as certain other technology providers, and some of it has to do with the regulators, some of it. So I think that's a continuum we need to think about when we're talking about laws and regulations and innovation, and how do you balance all three: the technology speed, the standards development, and the regulatory framework. And then lay across that the very fractious trade environment we have these days, which is not just due to the United States, but it's a very difficult trade environment, which is fracturing a lot of the relationships that existed for many years that generated these technology improvements. So I'm going to stop there. I can do an AI deep dive, because I know there are people in the audience that want to talk about that, but I thought I wanted to lay out the structure, because this is how I tend to think about these issues in my work. So,
Look, that was terrific.
sorry, I know I talked fast too. Sorry.
No. That's fine. That was terrific. What I thought I would do is ask a couple of questions and then make an observation about your career in Washington that you might want to comment on, and then open it up to the audience. Although I have many, many questions, but I'll just ask two. One thing is that I know that when you were in government, and you were in government for 25 years or so, I think.
Yep.
You represented the United States in international negotiations with the European Union, with South Korea, with China. I know some former Soviet republics, and I think I'm leaving out one.
No, that's great.
Okay, but I was going to ask you to tell just a couple of stories about maybe two negotiations that you're interested in, to kind of give us a flavor of what happens in the room, what kind of bargains you had to make, and anything that you want to draw from it.
Yeah, sure. I mean, So as I mentioned, I had a long career at the Department of Commerce, with the International Trade Administration, and also at NIST. And so the first big negotiation I was on the big team with is the US European Union Mutual Recognition Agreements. These government to government agreements. It's way back in the mid to late 90s. And it was a seminal achievement. There's never been a government to government mutual recognition agreement negotiated to date, and it covered 6 sectors, which was interesting issue of complexity. It took the negotiating team, which was a broad, I mean, I was part of the team. There was a big Commerce Department team, U.S. Trade Representative's office, each of the individual agencies that regulated in those particular sectors. So telecommunications, Federal Communications Commission led the telecom negotiations. Electrical safety, which we didn't succeed on for a variety of reasons, because, for a variety of reasons, we had medical devices, Food and Drug Administration led in that area, and there were several other areas where we were. It took us 6 years. I remember our private sector counterparts who were waiting for, some kind of waiting for the MRA negotiations, and we would say to them, don't wait on us. If you can make a commercial agreement, do not wait on the government discussions, because it's just a long slog. They were looking for reduced burdens in terms of from the US exporting products to the European Union. I'm sure the European companies were looking for the same increased efficiency, reduced burdens. And we did achieve this in the end, and that took another 2 years to implement. One of the negotiators, Charles Ludoff, who was at Commerce and was heading part of the negotiations at the time, we're in a big discussion with the European Commission over in Brussels. I can't remember which sector it was. I think it might have been electrical safety. And he finally said, "This is all kabuki theater." There's a lot of posturing. There's a lot of, and it was, in a sense, there was a lot of posturing to get to a technical agreement. But there was never enough. There have been a series of other smaller MRAs that the European Union has initiated with Canada, for example, and a couple other countries. There's never been another negotiation like that. I think because it took so much out of everybody. And what we achieved, MRA was also said to stand for My Regulation Supply, Mutual Recognition Agreement. Federal Communications Commission was agreeing that its regulations applied. All it was agreeing was that the European companies could access European testing labs that could test to US requirements. That was an improvement. You used to have to go to US labs to test US requirements. And from the US perspective, US companies were allowed to test and certify their products in the US, but to European requirements. We didn't eliminate any requirements. We just facilitated testing and certifying.
Oh, so that's interesting. So it's mutual recognition, but it was more mutual recognition.
My
for
regulations.
testing.
Yeah.
The testing too.
Yeah.
So basically what that meant is if you had a widget that you made in the United States and you made it to US standards, though, you also were thinking of the European market where there are a different set of standards.
Yeah.
And what you could do was widget company could make them to European standards, is what you're saying?
Yeah.
And then you would test them in a US lab?
Yeah.
Okay.
So,
Okay.
it's a piece of telecommunications equipment, a radio, a piece of there's going to be attached to the network in the US. The FCC had requirements. The Europeans had slightly different requirements. So, but the US, under the MRA, the US testing lab could test to both.
But of course, that's very different than what Europe agreed to itself when it talks about mutual recognition. Right? Because internally, right? Because the European Union actually undertook a massive standards program to harmonization and mutual recognition in the early 1990s, because the standards, the different standards in the 12 states then, now the 27, were acting as non-tariff barriers to trade. So let me give you an example. And I'm just going to throw out one that might not be sort of factual. Correct me. If you were a German company and you wanted to build a big building and you wanted to use a girder from France because it might be cheaper, might be made to your particular environment, you actually couldn't. Because the French girder, even though it was safe, wasn't made to the same German standard. So what the Europeans did was, for a whole range of standards, they said, look, if a standard's made, if a product is made in one of our 12 countries, and it conforms to that national standard, we're going to recognize it in our country. And so that opened up trade to a whole bunch of stuff. Think of all the things from jams and, well, not jams and jellies, that was
That's a different one.
No, I
Here,
know.
it's also a different
Jellies
one.
helps you that connection. I still remember. But think of that, how it gets rid of so many barriers to trade if you're able to do that. So we agreed not to that,
No,
but that was a huge issue in the 90s.
Right.
Huge issue,
right, it was the European Commission actually tasked European Regional Standards Organization to create regional standards which would apply across the entire Europe.
Yeah.
So it's the national standards that conflicted had to go away. That's
Yeah.
what,
Yeah.
but
That too.
it didn't, it was the cross-border neutral recognition was different.
It was different, right? I really oversimplified.
Yes.
Completely factual, yeah.
So
that's right.
it's, yeah.
That's right. Right.
And then you want just one more example.
Yes.
I mean, I spent, China has been interesting. China, this was
Yeah.
a while ago before, but China had joined the World Trade Organization in 2000, but they were given, 4 or 5 years to come up to full compliance with the World Trade Organization. So we had negotiations with China for many years, Commerce Department, State Department led, depending on the technology. And I still remember talking to a member of the Chinese government who worked on, there's an administration that handled regulations and standards and conformity assessment in Chinese ministry. And she was giving a presentation on the activity in China at the time. They were trying to move a little bit more toward the market and away from state administration. And she said, we like competition, controlled competition. But they were moving, they're moving away from no competition whatsoever to managed competition. That was a step forward. It's still very far from the US approach, but it's just, there are lots of it. And South Korea is also interesting because they were actually, the time that I was meeting a lot with the government folks in South Korea. They were actually, we have a law in the United States that was passed in 1995 called the National Technology Transfer and Advancement Act, which directs federal government agencies not to develop their own standards, to rely on voluntary consensus standards. It's been in place for 30 years. And South Korea actually adopted a law which was verbatim what the National Technology Transfer and Advancement Act said. They were very quick to move to more market-driven and more public-private cooperation. And you can see the effect in terms of their technology companies were quite competitive locally. But they were very forward-leaning in terms of the discussions. The Europeans, I really have enjoyed and still enjoy talking to the European Commission and talking to the regional standards bodies, but they take a more risk-averse approach for a variety of reasons. But it's a more risk-averse.
I wanted to also just point out how things have changed in China now. And let me just say a couple of things. And I know they're meeting a managed position, but it used to be the case, now China really participates in international organizations to try to develop standards. That will be, for the good of their products, right? Mary might talk about that later. She gave me some really interesting things to read about it now. And we're very cautious about that. We worry that they'll achieve dominance in international organizations. We wonder if we should try to exclude them from international organizations, which ends up not being a good idea, which Mary can talk about later. But it wasn't always this case. So I worked a little bit on China and advanced technology in the 1980s, when this was not the case. So in 1980-81, China really started its electronics, its electronics industries. And they were exporting some things to the early 80s. And then they really faltered. The products weren't selling. Things in China weren't good for that sector. They kind of closed down things. They applied for money from the World Bank to have the World Bank give them aid to jumpstart their electronics system. And the big donors in the World Bank, including us, said, yes, this is a good idea. We want to jumpstart Chinese electronics. So think about how things have changed now, right? We're so terribly worried about China. We're so terribly worried about their technological edge in certain sectors.
Yeah.
But in 1987, the World Bank said, okay, bring 40 of your people to Washington, D.C., the World Bank headquarters, and we're going to arrange for you a seminar for 30 days with some top US technologists about what you can do to jumpstart your industry. And they hired a small consulting firm. It actually was before I went to work for Commerce. They hired me and my senior person. I was a vice president. He was former president of Xerox Electronics. And so we met with them for 30 days to try to help them develop electronics technology. And we started to talk to them about the current state of things in China. And they said that they actually used two standards in China when they were manufacturing electronics goods. One was for the domestic consumption, things they weren't going to export, and the other was for foreign consumption. And we said, oh, okay, well, the standard that you're using for foreign consumption, that must be a tougher standard, you know? And they said, oh, no, to the contrary. We don't expect repeat customers. We send them really crummy stuff. And the man I was working with said, no, you can't do that. One standard, it's more efficacious. But we were flabbergasted. The Chinese are way more sophisticated now than they were in 1987. But things that we talk about now are just a snapshot in time.
Yeah.
Technology evolves, standards development evolves. All right, so we've talked enough.
Yeah.
I'll save everything that I have here for later, if we get a chance. Otherwise, over dinner. Great.
Questions?
And can you identify yourself and also say if you're on faculty and what you're teaching, or if you're a student?
Sure.
Thanks.
Hi, my name is Rebecca McKinnon. I'm a friend of the center. I'm not directly affiliated with Berkeley. I'm currently affiliated with Harvard and was until recently at the Wikimedia Foundation running global public policy. So that's kind of where my question is kind of coming from. Relates to another set of standards not mentioned here, human rights standards.
Oh, yes, okay.
And relatedly, sustainable development goals.
Yes.
And of course, we're in tough times for human rights standards and the sustainable development goals. But that being said, I'm curious to know your thoughts on, for those of us who would like those standards to actually be followed and become part of what industry is, using to kind of shape the direction of safety, security, and interoperability, for example, should be very compatible with the objectives of sustainable development goals and human rights standards. Curious your thoughts about how we might start to move the needle towards getting there.
So that's a great question. So I have a lot to say about that. Let's see. So there's, this in the UN Commission for Human Rights, the UN High Commission for Human Rights, which has a long trajectory of human rights policies and practices and standards to some extent, not necessarily what I talk about in terms of technology standards, but standards. And then the International Labor Organization also deals. And so the corporations that I talk to, and many of them are members of ANSI, are also aware and engaged where relevant in the human rights activities, because I think the responsible corporations are interested in maintaining human rights. Many of them, historically have run into issues overseas. If I look at the chemical with Bhopal, if you look at the chemical sector, for example, actions they've taken overseas have been come back to bite them in the US context. So it's not that there's no interest from the corporate community in human rights standards. It's more what I've heard from companies in particular is that in their place, human rights and human rights are relevant in artificial intelligence, or human interests are relevant in artificial intelligence. And And I know US technical groups that look to provide input to artificial intelligence standards that are being written at the ISO and IEC level. Certainly the NIST delegation, this includes philosophers and other types of stakeholders that haven't typically been involved in technology standards, sort of edging around a long way of saying there is an interest and a continued interest. And one of the things that we do at ANSI is in particular technologies, we're trying to reach out to what I call beyond the usual suspects. So companies know how to want to engage in standards, maybe more difficult for small companies than big companies, but corporations have a particular economic interest. US government agencies in the US, technical experts, they get it for the most part. Universities, they get it, but it's a little bit of different driver for a university participant. Where we would like to engage additional stakeholders or civil society and other, which are concerned about human rights in other areas, that haven't been engaged in standards development activities, are somewhat skeptical of standards development because they don't feel that their voice has been heard historically. So I'll give you a specific example. Critical minerals. So critical minerals are mined, they're extracted, they're processed, they're often mined in the US, not so much mined in the US, that's the problem, but mined globally in areas where you have indigenous communities, indigenous society interests, you have affected communities that haven't typically been engaged in standards development activities. And I will say, even from the US perspective, there's a big push on critical minerals and critical mineral supply chains. There is an interest in engaging all the stakeholders, not just the mining entities, but also the affected populations and the users and the consumers of recycling wherever that happens. So there is interest, and some corporations do take responsibility for the effect that their products or processes have more broadly. But it is not an easy, it's not easy to engage civil society effectively because, as I said, there's a lot of skepticism amongst that range of stakeholders, and they haven't felt that the standard system has really given their voice a fair hearing. But it is there. I will say there are efforts going on. It's not evident at the high level, at the high policy level, but a lot of the corporate community still has interest in bringing additional stakeholders to the table in these areas. It's not a great answer, but it is still an area of consideration. Not across the board, but in areas where their constituencies have a very flat voice in the process.
Other questions? Yes.
So I'm Catherine Camp. I could see in person.
Yeah.
I am a Master's of Public Affairs student from the Goldman School. And so right now I'm working on a capstone project related to quantum technologies development in particular, and barriers for the domestic talent pool here in California for venturing into that market. Specifically, you had mentioned, QIS on, information, and just kind of like the positioning that it seems to be, unlike AI, which has a lag, there seems to be a more proactive approach. So understanding which areas in where you're seeing, I guess, this, is it specifically in quantum computing? Is it in networking? Is it in sensing, like those things? Or so that in terms of those areas, and then where do you see the gaps?
Well, yeah, that's a great question too. And I will okay. And I mentioned that standards are more of a leading indicator in quantum information science than they are in artificial intelligence. To the point you made, quantum information science has subsets of very different computing, protecting computer systems from quantum, quantum attacks. So quantum sensors, quantum networks, they're related, but they're all different, have different standards, challenges. I will say, and maybe it's because of, to some extent, what's been going on in AI for quite some time, and the standards that have developed there. The quantum community, which is still pretty small, has come earlier to the realization that standards are important to help facilitate technology commercialization. And so organizations like QED's, the Quantum Economic Development Consortium, is working in this area to identify standards. The NIST and created a standardization center of excellence a couple of years ago, and they just published a quantum information science environmental scan, which is worth looking at if you haven't seen it. It just came out like about a week ago.
Okay.
So what that document does is look at all the standards efforts, and there aren't that many yet in quantum, which makes it easier to identify who's doing what. And then it looks at what the needs have been identified and where the gaps. So I don't have that at my fingertips, but there's a nice environment. There's one on AI too, which came out I think about a month ago. But that's a good starting place to look at what the various subsets of quantum look like and what the standards are.
Yes. Okay, great.
No.
Hi, I'm Ryan. I'm a grad student at Berkeley. I'm in the Global Studies department, but my concentration is security policy. So it's been really interesting to kind of see the, the connection between the two, like really just kind of like taking off and taking by storm at the minute. I'm really interested in like open source frameworks, particularly on like from the Department of Water perspective. So I don't know if there's like insight you can share to that, but specifically like, do you see open source frameworks as like strengthening or undermining global standard setting, particularly when states like China promote more like state-centric models versus like of technological government versus like other types?
Yeah. So open source is as software and also as standards is fascinating. And if you're studying in this area, you probably noted that going back to the Biden administration, maybe the first Trump administration, I can't remember, certainly the Biden administration, there was a lot of discussion of open source and open source used by federal agencies. And coming from NIST has had a big role in defining trusted open source, what you look at. But yeah, so because there was a big push for federal agencies, particularly, to use more open source software. But it has to be trusted open source software. So how do we define what that means? And I think that's still an area of interest. There's a double-edged sword here, because open source really facilitates broader usage of the underlying technologies and broader connections. It also brings with it, just because of the process by which it's developed, some risks. And it gets back also to that topic I talked about in terms of change. Open source by definition is individuals participating in developing open source software or an open source standard, but it's not static. I love this terminology, it forked. So you can, individual technical experts or a group can take it off in a particular direction. That's part of the beauty of open source. It's evolving and it's a living entity, but that creates security issues potentially. So you have to frame it in terms of what are the guardrails for validating open source and how it is applied, particularly in the federal system.
What in your like expertise, what are some of those like guardrails that you've seen to like be highly favored by federal agencies? Or then like also then do you agree with that necessarily, or do you think that like things could be shifted for like better? I'm in the process of developing a software at the minute for the blue review, so it's an interesting question to know like the risks. Obviously there's like a lot of risks involved in that, but then like in addition to like what is like best practice in
I would point to this document. So I have a bias because I worked at this, but I mean they have this does a whole series of
seeing a lot of that.
And federal agencies as well as the private sector tend to look to this for unbiased measurement and technical expertise. So it's just in their wheelhouse to be dealing with open source software as well as open source standards as an extension of the work largely out of the information technology laboratory, the work that they've done historically. So I would refer you to the documentation. It's still an ongoing set of projects, but the point you raised that I didn't address specifically is showing open source software and then trusted open source software or open source standards. There's less trust in open source deliverables that come from other countries. So and I think there's a lot of distrust, certainly probably at the department, at the Pentagon, of, open source software coming from certain suppliers. Whether that's valid or not, they have that, but the department, any department needs to put in place ways to evaluate software so that they can determine whether it'd be included in their supply chain or their suite of products and processes. It's a complicated issue. So, and the policy tends to go back and forth. Yes, open source is great. No, maybe not so good. It's just it's a sort of a different balance. But I think it's here to stay. It's affecting every technology area. And what I find really good is there's a recognition in the standards community of the value of open source, and that community where it intersects with the formal standards community. And there's also recognition, at least within the federal government, of the value of open source products and processes. It's just, I don't think we're quite there yet.
Question. Yeah. So my question is sort of career guidance oriented. So here at Berkeley, I've had the honor of meeting some really incredible like PhD students, technologists who are innovating technologies that someday will be ripe for conversations around standard setting or even regulation. And I found that, we still have a lot of academic silos. We try to get out of them. There's a tech policy certificate at the Goldman School that has a lot of crossover between more policy, social science people and tech people. But there's a lot more room. I've talked to like somebody developing cryptographic techniques and had all these ideas about what the limitations of standard setting, regulation, and safety might be, but didn't have avenues to share those thoughts or time to write a paper about them. So just like wondering how people here could be part of conversations about things that they're experts on, but maybe are a bit separate from.
Well, that's great. And I do take the point. We've been, not just the community, community is looking, including the community is looking to engage, as I said, more stakeholders. It's easy to get companies engaged. And then, so within the standards ecosystem, we're all looking at how to engage small companies because they don't have the resources or the bandwidth necessarily to be actively engaged, but to be just aware of standards in their particular technology area. The argument for federal agencies is a pretty clear one, although budgets impact whether technical experts can participate or not. But it's a harder sell with universities. Academics, I guess including students, but certainly academics are more logically driven by research dollars than by just, I have this interest in a technology and maybe I should take it to IEEE, participate in standards development activity. So it's trying to find what's the value proposition for a university perspective to engage them more actively in a standards development process. Some areas that I've seen work in more frequently in engineering schools is there are, I'm sure it's true at Berkeley too, there are engineering schools that have joint projects that individual companies will developing robotics or products or processes will fund at a university, and that's a funnel, an avenue to engage in relevant standards development activities. And even professional societies, the Society of SAE International does fund some activities at universities joint for students. There were ways to engage or get more awareness of standards development processes. I think there are opportunities. Certainly, NIST has opportunities because they crowdsource a lot of information, and you can get on a mailing list for AI, for example. And they did a really nice webinar on AI standards maybe about a month ago, and there were 700 people on the webinar. But you could just share your email address, and they will include you in their follow-up information push. It's true also for some of the DOE national labs have the push to universities, and that's another area to be aware of. But it's been more difficult, I think, because it's a more diverse community to sort of point to here's where you should get engaged. It works best in the engineering space.
Take a stab at that too, which is that people have a particular research interest or particular expertise and you start to figure out who the major players are, both in terms of organizations and people, you can contact them. I mean, it's much easier now than it was 50 years ago pre-internet to figure out who the major players are or contact their offices. And I can speak about it just from doing research more recently and from a long time ago. I mean, most recently, in the mid 2000s, I was really interested in the causes of the financial crisis, 2007, 2009. That is not what I spent most of my career writing about or thinking about or making policy on. But I lived in Washington at the time. I did a lot of reading. I found out, oh, who was interested in this at the SEC? Who was working on this at Treasury? What about over on the Hill? And just wrote to people. People are always happy to talk about what they know. And they're always interested in hearing about what you know, because they're just people doing their job too. It's really easy to do research, I found, in Washington. So, give it a stab, go further and see who writes back. You'd be surprised, I think a lot of people will. They want to know.
Just a follow-on
Yeah.
comment from my own experience. I think there's a lot of matchmaking to be done between, say, PhD students doing the technological side and then people looking at geopolitics, foreign policy. It's a great match because the social scientists will have an idea of how to write, say, like a white paper or a thought piece and can kind of like extract the technical relevant information from somebody that doesn't have that language. They don't write in that language. But can convey their thoughts. And so I think there's a lot of journals, student journals that are great to start testing out that stuff. Tech Policy Press is also really open to submissions too. So for developing thought leadership, maybe everyone needs to be thinking that way.
Yeah, and there's a lot of, there are a lot of think tanks in Washington, which is that produce a lot of analysis, but there are a lot of publications that are very Substack, framings that we can look to those, and that's where an area. LinkedIn has some interesting stuff. It's an area of sort of just trying to pick up who's doing what. So yeah, I agree with that. It's and I agree with the language issue too, because way back when I was still at NIST, we were first starting to talk about cyber physical systems. That's what we call it. This was I don't know, 15 years ago. And it's on manufacturing, there's physical systems, there's machine tools, and there's manufacturing systems, and then cyber. And as soon as you connect on the internet, it's a cyber system, a cyber physical system. So the engineering lab brought together a bunch of stakeholders in that area, and they were engineers, like mechanical engineers, electrical engineers, et cetera, and then computer engineers. And even those engineers spoke a very different language. So they were sort of the very first meeting we put together, I was just observing, they're just talking fast with each other. It's a very different language. So to your point about social science, I could easily write a policy paper, put together an options paper, try to synthesize how these all fit together. It's very different coming from a technology perspective to be able to articulate in the same terms. And it's important to have sort of some coming meeting of their minds. You reminded me, I want to mention one thing. You talked about tech diplomacy in the title of the thing, and I meant to mention it, I didn't. So tech diplomacy in the geopolitical policy area is pretty much very elbows first and a lot of blunt competition. But one of my colleagues in the corporate sector calls all of his staff who participate in standards development activities, and I mentioned there are a broad range of areas, they're all technology diplomats because they come to the standards table, they bring their technical expertise, but the real, not value, but the real capabilities that are valued in a standards committee is not how much you know, you have to know something technical, but not how much you know technically, it's negotiation skills, it's networking skills, it's consensus building skills. Can you communicate with other technical experts who come from Germany or Japan or Korea? It's a very much a soft set of skills that dictates success in standards. So that's important to remember that. I think it's true for technology folks generally. The soft skills are real important.
Yeah. Other questions?
We do have all the consulates in San
Yes.
Francisco that are essentially tech consulates. And,
Yeah.
you know, I think that's really interesting for students too, to connect with them and see what support they need.
Yeah,
Yeah, in fact, the European Commission opened a tech consult a couple of years ago because of the importance of Californians to it.
so one thing that's interesting about Mary's career is that she started as a civil servant.
Yep.
Straight out of, she went to Vanderbilt and then she went to Princeton to the, it's then called the Woodrow Wilson School. So she has a degree in public policy. And then went to commerce as you were a trade specialist or economist. You were
No,
trade
it's that's really right.
right? By the end of her career, she was chief operating officer at NIST. So here she was, social scientist with an agency full of engineers. NIST is part of the Department of Commerce. And the positions that she had over the course of her career are often reserved for political parties. She was deputy assistant secretary of for manufacturing and services trade at the Department of Commerce, which is often a political position. So what was your secret for getting into high positions, starting out at what, a GS 12, 9 at GS 9, working your way really all the way to the top? And and you might want to say something about nonpartisanship, bipartisan.
So, well, I mean, I guess what I could have said about my career is it was, how do I say, not opportunistic. I was always open to different opportunities. So, I mean, I started at the Department of Commerce because I had a colleague who had been in the job she vacated because for a variety of reasons. And so I managed to move into that job at the International Trade Administration. And then we were working on the European Union Internal Market program, which not fired, but benefited from working across different parts of the International Trade Administration, not just focusing on my particular silo. So working with the global markets people in a range of other areas. So I was always open to collaboration and to opportunities. And I moved out to NIST because there was an opportunity. So I was offered an opportunity and decided to move in that direction. So I think part of it's always being flexible and open to new opportunities. And what the point I think you were getting at, I mean, I was a civil servant for my career and worked through and a large number of administrations, always not partisan. Civil servants are not partisan, just work on the technical issues. As the administrations changed, you would run into some, not issues, but so when a new administration comes in, even particularly when it moves from Democrat to Republican or Republican back to Democrat, they look skeptically at all of the programs that were led by the political appointees of the previous. It's just expect. And so the civil servants are just there doing the job. We had at ITA a really nice program on manufacturing sustainability in the Bush administration, which benefited from a collaboration with the Environmental Protection Agency and the Department of Energy and the Department of Commerce. And they would go out across the country and talk to manufacturers who are interested in increasing efficiency and increasing sustainability. It was great. It was a great program. But the new administration came in and was initially very skeptical about what that meant.
Which administration?
That was the Obama
The
administration.
Obama administration.
Yeah, which seems counterintuitive,
Right,
but it was.
sustainability, that's a good word.
It's not for 6 months. So we had to sort of just on the, just kind of low key that particular terminology. So you can run into terminology issues as long as the program itself is robust. It can survive, but you have, as a civil servant, you have to be flexible. You are working for political appointees. The direction varies from administration to administration, and so you have to either be willing to move in that direction or to exit your position. I was lucky enough to be able to continue to be nonpartisan. I think one of the benefits is NIST through every administration is nonpartisan. This is a technical agency. It sort of does, but it doesn't do policy. So, and so this has been able to sort of manage through the winds of various administrations somewhat better than some particular parts of other agencies, just because of it has a very good reputation on the Hill too. Congress bipartisan, very supportive of the science agency. So that was good. I think that part of commerce was beneficial. Yeah.
Yes.
I had a question. So I was wondering, like you mentioned that the United States is like geopolitical power, especially as it regards its like technological prowess is
Yep.
decreasing.
Yeah.
How into the future, especially within the next few years regarding like AI policy and like capabilities developments, can we still leverage our ability to like encourage agreements amongst like United States AI frontiers companies and establish treaties between the United States and China as a whole in order to create a sustainable future where like AI is being regulated and supervised internationally rather than
Right.
continuing forward with a sort of AI arms race
Right.
that we're not entirely sure how to control.
Right. And that's another great question. I'm a glass half full person. And so I tend to see going forward, we could reach that, head more in that direction versus this AI arms race activity. And it'll be in part as a result of leadership by private sector companies. Some of the frontier developers are many of them are very interested in agreements and guardrails being established at the international, at the global level, and that pressure will continue to build on various governments for the benefit of a broader agreement. We're not seeing it yet, but I'm seeing influx of it in terms of particularly the frontier model developers. And China, I think we didn't talk much about China, but China as a government and as a country has changed dramatically in the past 30 years. And you do see this push and pull in China between government control and private sector, a little bit more private sector freedom. But you also see China is now, and they've been very clear about their intentions and their plans through the 5-year plans in terms of technology, moving in technology areas and moving to engage more effectively in international standards development. They've been very transparent about it. But China has I think maybe seeing the benefit of being more responsible. I don't mean to be pejorative in that way, but that because now they are in say like advanced communications or AI and some other areas, they have a lot of intellectual property. They have a lot of leadership in these particular areas, and so they're not scrambling to catch up. They're actually leading in some of these areas. But I would think that the government and the companies might see a benefit in greater collaboration, because there's a little bit of a safety net if you're collaborating across the board. And then the global research community is critical to advancing all of these technologies. So cutting off access either from this perspective, this direction, or the other direction to the global research community is just a recipe for slowing down technology innovation. I just think I'm sort of positive with a move in that direction, partly because of the pressures from big companies. Yeah.
Yes.
You touched on this a little bit earlier, but I wanted to go back to the cybersecurity piece.
Yeah.
Yesterday, Anthropic
Yes,
released
I know.
the model cartography for Methos.
Yeah.
And like those that don't know, they elected not to release it to the public,
Right.
because it like made clear some serious vulnerabilities that have existed for decades.
Yeah.
That I'm reading about now, we're like working with other companies to patch them. So given that generally the open source model capabilities trended like 6 to 9 months behind
Right.
frontier models that Anthropic Google put out, how do you see standards not only relating when it comes to competition between the US and China, because a lot of the Chinese companies do have open source models, but also just more broadly in the world as these open source models begin to diffuse, and so bad actors and non-state actors will have access to cyber capabilities. So like Anthropic's using it defensively,
Yes.
but once this time next year
I
they're
know.
able to be used offensively, how do you see that
Yeah.
world looking?
Now that's a great question. We were just talking before the session started about the Anthropic announcement. So that's why I was talking about responsible developers, understanding what they have developed and the potential for bad actors to use it. So to some extent, standards play a role. I mean, there are frameworks for risk managing, identifying risk and managing risk, and you know, techniques for auditing and techniques for protecting security. But really, it's a more of a corporate and government responsibility to try to manage this entity or the development. So as I don't have a better example, but it's pretty scary right now in terms of what is being developed and how quickly things move. I give Anthropic a lot of credit, not just for this activity, but for its stance it's taken on how its AI models are used by other organizations.
Including the Pentagon.
Yeah, including Pentagon. Yeah. So I think the only way forward won't be effective if only governments take action or only companies take action. It has to be a joint enterprise between public-private partnership and setting up responsible systems and punishing those that are not responsible. But I don't have a good answer for you. I just think it's the Wild West. Right? But I do think that there are a lot of responsible corporations that don't want to see this get really out of hand. And then you add quantum in there, and you have quantum for time rooms. So there you go.
And it is now 2 o'clock.
Oh.
So we will stop.
That was so good.
Oh.
Yeah.
It was terrible for me. I don't know if it's terrible for me.